Hello guys, welcome to today's video. I just want to explain you guys is how to work with system of linear equation properties that we use in the equations. But now I just want to focus guys in exactly this. What is a system of linear equation? Okay, here we go. This definition in mathematics, a system of linear equation is a collection of one or more linear equations involving the same set of variables. Okay, what is that, guys? Instead of just having a single expression like this, we're going to have two or more than two, at least two, and we're going to have the same variables. Okay, that means that we're not going to work only with x or only with y. We're going to work maybe with x and y or different variables. Okay, let's take a look at this example. I got some examples here. We got this first system of linear equation. Take a look. X plus y equals to 2. Okay, what values can have x and y here, guys? That makes 2. Okay, this one plus this, I get 2. Oh, you can say, Mister, I can get 1 and 1 here. Okay, that is true, right? For the first equation is x is equal to 1 and y is equal to 1, we can get 2. But what about the second one? Okay, this is the new things that we have to do, guys. When we are solving a system of linear equation, we have to find a value that make the first equation true, like this, and also the second one. Okay, but how do we do that mentally, or what do we have to do? There are different methods, guys, that we can use in order to find out this value. Let's take a look at this. 2m plus n equals to 6. What values can we replace in m and n in order to get 6, and m minus 3n that we can get 4? Okay, maybe mentally it's a little bit hard to do that. Okay, but that's why we have different methods. Okay, but how do we find those values? Okay, that is the question. How do we can find that values? Okay, okay, we have to solve, or what we have to do? Okay, we have different methods. Okay, I'm going to start explaining you the first method, and this method is called the solving system for linear equation by graphing or graphically. Okay, this is going to be our first method. And how do we do that? Okay, let's go here. Okay, here I got a kind of a definition, guys. When we're graphing two equations, specifically in two equations. We're going to get two lines, right? Because there are linear equations, we're going to get two lines. We have three cases, guys. First case, second case, and third case. What is going to happen when we have this? Okay, one line is like this, the first one, and we have another one. As you can see, we have an intercept, a point of interception right here, right? What happens if we have the same, when we have the same lines and they got the same slope? What do we have to do? Okay, in this case, guys, this is the second particular case, and we can also have a third case. And when we have the lines that, as do you remember, when we have the same slope, okay, there are parallel lines, right? Okay, this is the third case. What happened with these three cases, guys? When we have this special case, the first one, we're gonna say that we have one solution for the system. And exactly this where the graph crosses, that is the point of solution. What happened with the second one? The lines are exactly the same. Okay, we have infinitely many solutions when we have the same line, because all of these points are going to make the system of the linear equation system through. And the third case is that when they never cross. Okay, what happened? There is no solution. Before we do that, I'm going to explain just example. That is 3. And what is my slope? -2. But it's a fraction over 1. Okay, with this information in our hands, okay, now we can graph the second linear equation. Okay, my y-intercept is going to be 3. Okay, 1, 2, 3. Here's going to be the point in 3. Okay, I'm going to plot the point. Okay, 3. And the next point, okay, we have to move according to this slope. -2 units down. Okay, -2 from this point. 1, 2. And how many units to the right? Okay, just one, right? The denominator. Here's going to be the second point. Okay, we're going to graph the second point. Okay, here. And this. And now we're going to make the green line. Okay, I'm going to move a little bit here. Maybe you get to see better. We're going to make the second line. Okay, and this is going to be my second line. Okay, now we have graphed the two of them. What is missing, guys? What do we have to do? Okay, in order to determine, okay, let's go back here to this information. What is going to be my solution, guys? My solution, guys, is going to be the point of intersection of the two graphs. That is going to represent my solution, okay? Where the graph crosses, that point is going to be my solution. Okay, let's go here and let's take a look. Where does this graph match each other? Where does it cross? As you can see, maybe the blue one, I didn't do it perfectly, but as you can see in this point, the two lines crosses, right? And what point is this where the two graph crosses? That point is how many for x? Okay, let's identify that point. Okay, that point is, okay, I'm gonna use a point. Okay, the point form. Okay, what is the value for x in this point where the graph crosses? X is 1, right? Okay, 1 for x. Okay, that's gonna be 1 for x. And how many for y, guys? Okay, how many for y? Okay, for y this point is 1 units. Okay, 1 comma 1. All right, this is my point. Okay, that is going to be my solution. Okay, in the next video we're going to check that solution out. Okay, solution is, what is my solution? The value for x is, this is the value for x, right? It's 1. Okay, it's 1. And what is my value for y? It's 1. Oh, it's also 1. Okay, y is 1. Okay, if you want to check this out, you can substitute those values into the equation, and you're going to realize that this is true. Okay, if we substitute 1 here, 1 plus 1 in y, oh, that is true. This makes my first equation true. Let's check the second one. X is equal to 1, right? 2 times 1 here, we get 2. And the value for y is 1. 2 plus 1, 3. As you can see, these values make my equation true. Okay, and this is how do we solve by using graph. I'm going to explain with a second example, guys, and we're going to check your answer. But in this video, I'm going to stop, guys, and please check out the next video. Thanks for watching.